just write. Anyone would like to tell us what is a piecewise defined function? Or give us an example, any example of a piecewise defined function.
So when there's more, one or more, or sorry, usually like two or more, right?
Two or more. Very good.
Functions.
Yes, pieces, right. So piecewise defined function.
And depending on the value,
yes,
there should be a range.
Yes.
For which function
yes.
you will use.
Yes, absolutely. Very good. Can anyone give us an example from real life situations of a piecewise defined function? Can anyone think of what happens on April 15th every year? Well, sometimes it may be delayed to the 20th. Every year that happens on the 15th. And that is an example.
That would be the tax day.
Absolutely. The tax code is a piecewise defined function. For someone making, I'm making up numbers. From somebody making between this and this, they pay this percentage. Between this and this, they pay this percentage. Between this and this, they pay this percentage. So that is an example of a piecewise defined function in real life. So can anyone give us two branches?
Well, let's just start out. If you make less than $16,000, you
no, just a simple function. Just a simple function. Okay. That was just the real. Yeah. So let's say x squared.
Hey, my favorite day of the year. Not okay.
Good. So I made one up. So what type of function is x squared minus 1, and what type of function is e to the x? If any of these colors, they're all new, if any of these colors do not show correctly, or let me know and I'll put them on the side.
The top one is a polynomial.
Yes, it is a polynomial, correct. Poly. Specifically which type? Awesome. It is a polynomial function. Specifically which type of polynomial function?
Binomial.
It is a binomial, but which type of polynomial function?
Exponential.
This is the exponential when the power is the variable. If the power is the variable, that is exponential. So x squared.
It's not linear.
Is it even?
Yes, go ahead.
Is it even?
Degree is even, if you want to say that.
I know the function.
Is it quadratic?
Thank you very much. How do we graph a quadratic function? What is the graph of a quadratic?
Is it a parabola?
Yes. The quadratic function either looks like this. We say it holds water, or it does not hold water. It has a minimum or it has a maximum. Perfect. So whenever we are asked to graph, so the question here is graph f of x. So this is what we are trying to do. Graph f of x. Whenever we are asked to graph a function, we have to start with, anyone tell us what we start with? Mandatory, always and forever. We start with the
Zero.
We always start with the domain. And the reason is I don't know what to put in here. I have no idea what to put in x, what to replace x by. That's my starting point. So in other words, if I want to build a home, I have to find a lot. And that is the domain. So for the function, for the house, the domain is the lot. But for the function, the domain is the domain, right? Good. So by looking at this function, I'm going to copy it one more time here because I already wrote a lot of stuff there. So x squared minus 1, x less than or equal to 0, and e to the x for x greater than 0. Can anyone change this notation into interval notation?
Yes.
Just tell me what to write, and I'll write it.
Interval notation would be parentheses, negative infinity, negative to negative 1.
S less than or equal to 0.
So that it would be 0.
Good. And then?
Would they square?
Very good, with a
square
bracket.
parentheses.
Awesome, awesome. Now let's change this one.
Negative, the parentheses, negative infinity, comma, 0, and then a parentheses again.
X greater than 0.
Starts at 1.
It would be parentheses 0, any closure parentheses.
I couldn't hear you. 0 to?
Infinity and then close.
Good. So x greater than 0, we cannot start at 1. And here's why. On the real line, 0 and 1, between 0 and 1, there are infinitely many numbers. Infinitely many numbers. So x greater than 0 means at 0, but not 0. In the immediate vicinity of 0, I cannot start at 1 because there are infinitely many real numbers that I will be missing. Good. So for now, you are probably asking yourselves, why is she changing this into this? So we all understand that this is the same with that, yes or no, and this with this. Is that a yes or a no?
Yes.
Okay, perfect. Now, based on what you see here, can you identify the domain of this function? When we talk about the domain of the function, we are talking about f of x. I'm not talking about this. I'm not talking about this. I'm talking about the domain of this function. Based on what you see here, what will be the domain of f of x?
All real numbers.
Thank you very much. So negative infinity to infinity. So f of x is defined on negative infinity to infinity. Perfect. Thank you so much. Who was that?
That was me.
Casey, thank you. Perfect. Okay, good. Now, see, 0 is exactly in the middle. This could have been 4. I would have plotted here 4, but 0 is right in the middle between these two. Notice that there is a bracket to the left, right under 0. It's not to the left, it's not to the right. It's exactly under 0. And the parenthesis, and they're touching. When these two symbols would not be touching, if they're both parentheses, then this would be maybe another number or nothing. But if we have a bracket and a parenthesis, or a parenthesis in a bracket, they will be touching. The next question is redundant, but it's important. Which piece, because it's a piecewise defined function, which piece of f of x is found between negative infinity and 0? From these two. I know it's silly, but I want to write it up here.
This one.
The first one, of course, it's the x squared minus 1. Of course, it will be silly for me to ask again. It will be very clear. It's e to the x. Now, on this side, I know how to graph this because the leading coefficient is positive. Will it be a minimum? Will it have a minimum or a maximum when the leading coefficient is positive? A minimum or a maximum?
Minimum.
Yes, it will be a minimum. Very good. So which numbers should I pick? Is there a number, a specific number that will be important here? Yes, I can find the x and y intercepts. That's what I meant, right? So how do I find the x-intercept for a function? And how do I find the y-intercept for a function? The x-intercept is determined how?
So you set y equals zero.
Very good. So if I have x squared minus 1 equals 0, I either factor or I move 1 and take square roots. How do I solve this?
Foil,
So x will
take
be,
it down to x plus 1. Oh, go ahead.
it's okay, go ahead. Do we have an answer for this equation?
The x equals 1 and negative 1.
Plus or minus 1. Very good. Awesome. Oh, I'm so sorry. I just saw that there is a chat here. Is the chat for me? Oh, it was for me. Oh, I'm sorry. Forgive me. Okay, I'm going to be more careful. Good. So we have x equals plus or minus 1, but x is between negative infinity and 0. So what do I put in? Do I put in both or just one?
Negative 1.
Just negative 1, and the answer is 0. Good. So now let's plug in 0. What do we get? We plug in 0. In x squared minus 1, what do we get?
Negative 1.
Good. On the other side, let's plug in 0. What do we get?
1.
Very good. And let's plug in 1, and we get e. Okay. Now let's graph it. And then we'll identify the range. So from left to right, step by step, I plug in. Again, if this color is not good or any color, let me know. So negative 1, 0 is this point. 0, negative 1 is this point here. Is it an open point or a full point?
A full point.
It is a full point. And we already discussed this is a quadratic function. And it has a minimum. Notice that I took this color and I put it aside. Now I'm going to use a different color for the rest. Good. So this is 0, 1. We plotted, the bracket told us that this is a full point. That was a full point. What about 0, 1, which is here? What type of point would that be?
Open.
That would be an open point. Good. And 1, e, e is 2.7, so the graph goes this way. This is f of x. And you see there is a jump. We're going to talk about this very soon. So the function has a jump. Will this function be continuous? This is a continuous function. I graph the entire function without raising my marker off the pencil of the paper or the pencil of the paper. So is this a continuous function?
No.
No. This will have a jump. Can anyone identify the range of this function?
Range
Negative 1 to infinity.
Yes. So when we determine the range of a function, we imagine that we are drawing horizontal lines starting from negative infinity. See if those lines cross the function. If they cross, those values of y belong to the range. No, no, no. Yes, at negative 1. Yes, 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 to infinity. Awesome. So this is indeed negative 1 to infinity. So please remember how to graph a piecewise defined function. These notes will be posted after class tonight. I'm hoping that you will look at the other videos on this. Any questions? Any immediate questions you may have? Anything? Any questions? Now, yes, there are other methods. Can you use them? Yes. But you may skip or miss this important information that is in these symbols. You may not graph a full point. You may not graph an open point. You may stop here or stop here, and that would be incorrect. Now, one other thing that I want to mention, if you extend the orange or yellow, whatever this is, to the right-hand side, or if you extend the part of e to the x to the left-hand side by the vertical line test, this is not a function. So that's the reason why you have to draw it in two different colors? No. But that's why I drew it in two different colors, to remind you that if they overlap like this, there is no credit. Because by the vertical line test, this will not be a function. Okay. Remember to stop me if you have questions. Okay, the next step I would like to talk about something called the average rate of change of a function. And after that, we're going to look at the next step would be after the average rate of change. We're going to talk about the difference quotient, but not yet. So can anyone give us a function and 2 points? X equals x1 and x2. Any function you want to look at. Okay, x squared minus 4x plus 4. And x1 equals 1 and x2 equals 2. Okay.